So number 2, we've got 3 to the negative 4. 4-step process. Follow along with your red pen. If you need to make a correction, make sure you're writing that in red. If you get everything right, put a little star, happy face, smile, whatever. Just so you know that, hey, I got this right. I feel pretty confident about the other questions. I know it's unfortunate we don't have time to go over every single problem, but we'll do what we can. And if you have additional questions after that didn't get answered, we can talk about it individually, okay? So 3 over negative 4. My first step is going to be, again, to make it a fraction. So put that 3 over 1. Anytime you need to make it a fraction, you're going to put it over 1. You're not going to put it over 2 or 3 or 4. It's always going to be over 1. Now we're going to flip these around, giving us 1 over 3 to the negative 4. After I flip my fraction, what do I do with my exponent again, Devin?
You make it positive.
Make it positive, and now we just have to expand this exponent out and evaluate. 3 times 3 times 3 times 3. Not 3 times 4, 3 to the 4th power, right? So these 3's multiply and give us 9, and so do these 3's, right?
Yes.
So then what's 9 times 9 going to give us? Very close, just 81, right? I think, or you did say 81. 81, yeah. Sorry, I'm hearing things. It's Monday. 81, that's our denominator. 1 over 81. Right? Is my answer going to be positive or negative? Positive, right? Because the base itself, 3, is positive. Right? So we know that our exponent, even though our exponent's negative, our whole fraction answer is not going to be negative. Sound good on number 2? Anything I can clarify about that?
No.
Perfect. Down to 5. Now 5 is a little different because we have a negative base. So you might assume, oh, my answer here is going to be negative. Not too fast. Let's take it step by step and see. We'll put this over 1 and flip it. 1 over negative 7 to the negative 2. After I flip my fraction, what am I going to do next?
Make the negative to a positive.
Make the 7 into a positive?
No, the negative.
That's right. Make our exponent into a positive. Now this is where we have to be careful because we're not doing 7 squared. We're doing negative 7 squared,
So,
which is negative 7 times negative 7. Right? Anytime we multiply a negative times a negative, what is it going to give us, everybody?
positive.
A positive. And what is 7 times 7? 49. So even though our base was negative to start, our answer is still positive. Right? Which is different than number 4. Number 4, we start with a negative base, but we end with negative 1 over 64 as an answer. Right? The reason why is because we have an exponent of 3. So when we do a negative times a negative, good morning, Delarrin. I'm going to have you join this group back here actually today, group 7. So when we do 3 of them, right, negative 4 times negative 4 gave us positive 16. But then a positive times a negative gives us that negative 64, right? I know I went through number 4 kind of quickly, but we weren't planning on going over that one. But that one's a little bit tricky because we do get a negative fraction as an answer. If you got positive 1 over 64, take a look at this. Make sure you see what I did there. I kind of jumped to step 4, but once you start seeing the pattern, 1 over 81, 1 over 49, negative 1 over 64, right? This pattern is kind of the same every single time. Until we get to number 9. Because number 9, what do we start with as our base? What's our base here?
1/3. Fraction.
Thank you, 1/3. We have a fraction as a base. So we can skip step 1 and just flip this around. 3 over 1 to the negative 2. And Delaney, we're going over worksheet 3 right now. So don't worry about the warm-up. We'll take care of that later. Just get worksheet 3 out so we can talk about it. 3 over 1 to the negative 2. Flip my fraction. What can I do with the exponent? Am I going to keep it negative? Or am I going to do something to it?
Make it positive.
Make it positive, right? 3 over 1 squared. Now, if we have 3 over 1, that's just the same as 3.
Square.
And 3 squared is equal to
9.
9. Just like that, no fraction as our answer, just a whole number of 9. So it's weird, when we start with a 1 on top, our answer is a whole number. But if we start with a whole number, our answer ends up with a 1 on top. Math is all about patterns. Just like our 100 numbers activity, you guys started to see a pattern that, hey, all my colors are in this corner, all your colors are in this corner, right? That's part of recognizing patterns. That's what this is all about. Okay? Now, number 10, we've got a negative x to the negative third power. Even though we have a variable instead of a number as our base, we're going to follow steps 1 through 4 exactly the same way. Put it over 1. That's step 1.
Then flip it.
Flip it over. 1 over x to the negative 3. What do I do with my exponent one last time? Turn it into a positive. Thank you. And now my step 4 is to evaluate the exponent, right? So if I expanded this out, it would be x times x times x.
That'd be 3, right?
Can we do anything with that though?
No.
I see head shaking. No. This right here is our final answer, right? A variable is a placeholder for a number. But if we don't know what that number is, we can't just randomly plug a number in and solve it, right? We leave it as a variable, just like that. Typically, we'd be able to expand out. Like if our denominator was 2 to the third power, 2 times 2 times 2, we could synthesize that to get 8. But if we expanded these x's out, we can't do anything. It would just be x to the third. That's our answer right there. So very quickly, if we follow that pattern, right, in number 10, we started with x to the negative 3. We ended with 1 over x to the third. What's my answer going to be for number 11? Skipping all the steps, and we just follow that pattern. What's my answer here going to be? There's going to be a 1 on top. That's right, 1 over k to the positive 2. We put it over 1, flipped it, made the exponent positive, all in one step. Anyone want to take a guess at what my answer is going to be on number 12? Go ahead, Ida. 1 over v to the positive 4. Take a look. 10, 11, and 12, all those answers look exactly the same except for the letter we used and the exponent we started with. If you noticed that pattern on your own, that's awesome. Otherwise, I hope you see kind of how this works and how it's all pretty much the same thing. If you don't see that, let me know. We can talk about it. Are there any final questions I can answer about this one? Just so, because I mean, we're almost through the whole thing. What's the answer to number 6? 1. But what about number 7? What's my answer here? Is it negative 1? No, it's just positive 1. That's right.
Every time, even if it's a negative.
Even if the base is negative, if it's raised to the 0 power, we get 1. Number 8, our answer was what? Anyone got the answer to 8 for me? Reason, thank you. 2. Right? Flip the 1 and the 2. And there's nothing to evaluate because our exponent's just 1. Right? All right. You can put your red pens away. I appreciate that. Please go ahead and give worksheet 3